Thank you very much. Okay, I'm Jean-Laurent Philippe. I'm the EME HPC Technical and Sales Director, and I'm going to walk you today through a presentation that covers the hardware and architecture specifics. As we are in a public environment, all of the information that I'm showing here is public, can be found either online or requested from Intel. And you will see, and I will mention the sources of the information, but you will see that information usually on many of the slides that I stole from my colleagues. I'm more a specialist of HPC and therefore server CPUs. So I will be, I can talk at length on Ice Lake, which is the new Xeon processor, third generation Xeon scalable processor that we started producing recently, that we are ramping up the production for, and that we will be launching in the next few weeks, months. And I will talk a little bit about what's coming after Ice Lake. But I will also tell you about where we are on the CPUs for laptops and desktops, and I will focus on Tigerlake that we have just launched. That's the 11th generation core processor. And I will talk about what's coming next after the Tigerlake processor. As you know, Intel has been in the design for integrated graphics in processors for a long time. And we are now getting these graphic solutions out of the processor into discrete solutions. I will talk about that, and I will focus on PonteVecchio, which is the solution for the Xscale type of machines that everybody wants. And then I'll have a few slides on other accelerators that are the FPGAs, the Stratix 10, and the Agilex FPGA. Intel has updated the logos, the brand names, and everything recently, and you can see here a lot of the logos that I will be touching today. Of course, Xeon for the Ice Lake, but also the Iris Max for Iris Xe Max for the Tigerlake, the Intel Core processors for the clients. We show here Optane as well as Pentium. There are also some FPGAs. But just to remind you that Intel is reinventing itself with the new logos and also the addition of the Xe line of product, which is the graphics architecture, in addition to the Core and Xeon, the typical Intel architecture processors that you know of. So first, let's start with server CPUs. And by the way, if you have some questions, unfortunately, I'm not as good at playing with the tools as Michael is, and I don't have a side window where I can see the chat, so please interrupt me. I'll be happy to take questions on the flight, but we will also hopefully have a few minutes at the end if there are any remaining questions. So let's look at the server CPUs. Ice Lake is the third generation Intel Xeon scalable processor, Ice Lake SP, therefore, and it is in production, as I said now, or ramping production. We will be launching it officially in the next few weeks, few months, but a lot has already been said about it in the second half of 2020 and earlier in 2021. Typically, we had some updates publicly at the hot chips during summertime, then around supercomputing in November, at the analyst forum a little bit later, and then at CES early in January. So all of this information is public, and it is very exciting to see that what we are providing with Ice Lake is really important in terms of features. Typically, we are going from 6 channels of DDR4 2933 in the previous generation of Cascade Lake and Cooper Lake processors, now to 8 channels of DDR4 at 3200. So that's a significant bandwidth increase that we are providing here. And in servers, and especially in HPC, memory bandwidth, or if we want to call it differently, bytes per flop, is very important. So trying to find a way of increasing the memory bandwidth at a rate which would be in the same range as that of the performance of the cores or of the socket itself, number of cores, then that would be great. We are trying to do that. In addition, we are also improving the core itself, and I will tell you a little bit more about it in a moment, but that's resulting in about 18% additional performance per core in terms of spec int rate, so generation to generation, and that's the IPC, instruction per clock, that is bringing a lot of performance increase here. As we will have very performant cores and good memory channels, we need to make sure that the I/O is not a bottleneck, and we are introducing the support of PCIe Gen 4 on the Xeon line of product with Ice Lake. Having a lot of memory is also super important, and therefore with the obtained persistent memory DIMMs, we are capable of reaching 4 terabytes of obtained persistent memory capacity per socket, plus 2 terabytes max of DDR4, totaling 6 terabytes. Yeah, I know HPC does not necessarily need that, but trust me, there are some other applications that need it. And also, we have seen some users very, very interested in putting a few nodes in their cluster, in their HPC clusters, that would do pre and post processing, domain decomposition, and things like that with a lot of memory. And having a dual socket platform which is capable of supporting up to 12 terabytes of memory per socket means that you can potentially have the same motherboard or the same system for heterogeneously supporting the same type of BIOS updates and stuff like that, facilitating therefore the work of the IT administrators. And with these safeguard extensions, we are now providing the security of the data when they are being crunched. Until now, the data was secure at rest, in transit, and now they are secured while being processed in the processor through some memory enclaves that cannot be tampered with. So very, very, very exciting features in this processor, which is manufactured in the 10 nanometer plus process technology, and that supports only 2-socket platforms, no 4-socket or 8-socket. Of course, who can do 2-socket can do 1-socket, and there will be 1-socket optimized platforms coming from some OEMs. But the Ice Lake processor is retargeted at dual socket platforms. We have a new core, which is codenamed Sunny Cove, and I'll talk about that in a moment. But as I said earlier, large performance in the core, great memory bandwidth, no bottleneck in the UPI, which has been increased, and increased performance in terms of bandwidth available and number of lanes available through PCIe Gen 4 support, which means a very scalable and well-balanced architecture at the processor and at the platform level. And as you can see, as I told you, this information is already public and is coming from Hot Chips. and you can see that it was in summer last year with the old Intel logo. Now it's a little bit different. So as I said, the new core, codename Sunny Cove, is a new core microarchitecture. It also brings new instruction sets, and around the cores, we have all of the rest of the SoC with the typical infrastructure that you know of in terms of the mesh that you can see on the picture here, enhanced from the previous generation, but still with the same architecture. And we are improving, as I said, the memory hierarchy and the IOs in order to provide performance and performance per watt improvement. Here we are showing a 28 core Ice Lake die, and this was, for the Cascade Lake, the maximum number of cores that the Cascade Lake processor could provide. You can bet that for Ice Lake it will be a little bit higher, but this information is not public. I'm not going to ask you for a quiz on this slide, but I just want to tell you a little bit about the improvement that we have made in the Sunny Cove core compared to the previous generation. And here you can compare the Cascade Lake with the Ice Lake. And you can see that for each core, we are, I'm sorry, for each core, yeah, for the core used in Cascade Lake to the core used in Ice Lake, we are increasing significantly its capability in terms of size of the windows, in terms of the number of scheduler entries, in terms of the number of registry files, in terms of the allocation queues, which are longer, the size of the L1 data cache, which has not been changed for years, is now increased by 50% from 32K to 48K. The L1 instruction cache, though is not changed, it stays at 32K. And in terms of L2 cache, we are also increasing it, L2 cache, we are increasing from 1 meg to 1.25 meg, knowing that the TLB is also increasing in size. All this results with all of these features here, with a lot of improvements in the capabilities, results in significant performance increase. As I said, 18% increase in instructions per clock on estimated spec-int rate. So that's great, but that's not enough, because we heard our customers telling us, yeah, but what we want to do is a very intensive AVX512 computation, and with Skylake and Cascade Lake, which are here in dark blue and red, then when going from applications that would use either SSE or AVX2 Lite to AVX2 High or AVX512 Lite, then the frequency drops, even though the performance increases. And when going to very high AVX512 usage, then the frequency drops again. And even though the FMAs and the capabilities of Turbo allow the performance to be much, much higher by using AVX512 on enabled applications than staying with AVX2, still some customers were a little bit frustrated that they couldn't get more performance. We have significantly increased and improved on that, to the point that with light AVX512 applications or high AVX2 applications, we are trying to maintain on most of the SKUs the frequency at the same level, no drop, while there's a little bit of a drop when we go to AVX512 high utilization. So that's a much better use of the capabilities. And as you can see, it's usually used at 512H when we do a lot of FMA and BNNI types of application or floating point multiplications. So this means that the frequency dropping less requires the same power for higher frequencies, higher performance. So the performance per watt is improving significantly at the core level and therefore at the socket level. And with more details on the uncore aspects of the CPU, we are integrating the PCIe Gen 4 controllers, as I said, and as you can see, there are 4 of them, which means that you can go up to 64 lanes of PCIe Gen 4, allowing a lot of good and available bandwidth for supporting the accelerators or the fabrics or the equivalent. I already talked about the 3 independently clocked UPI links that are also increasing their frequency by about 10%. But the big thing that we are doing here is instead of having 2 memory controllers on Cascade Lake, each of them driving 3 memory channels, we have here 4 memory controllers, each of them driving 2 channels. So that means that those 4 by 2 allow a lot more flexibility and bandwidth. And we have also significantly improved on the memory controller design, and you will be able to see that when we launch with the performance that we are showing, especially on applications that are extremely memory bandwidth bound. We have a very, very good and balanced design. Not necessarily important for the HPC environment, but we also support total memory encryption of the DIMMs, which means that if someone would be probing the DIMMs with a tool, then they would only be able to see encrypted data that they can't use. But that's at the discretion of the user. It's something that people can choose at boot time. I've not seen it much used in HPC, but it's a capability that we have. I already talked about the enabling of the obtained persistent memory 200 series, codename Barlow Pass, that allows a support total of 6 terabytes of memory per socket. So as I said, dual socket up to 12 terabytes. As we like to do things a little bit more detailed and allowing people and users to take the most out of the processor and the features that we are bringing, we are improving on the Intel Speed Select technology that we started providing partially in the Cascade Lake processor. In the Cascade Lake processor, the features were a little bit limited, less than what is shown on this slide, but the important thing was that you had to choose which profile of the processor you wanted to use at boot time, set it, boot, and use it. The beauty, and we've seen a lot of customers very interested here with that, is that with Ice Lake, the same features and even more are available, but they can be changed at runtime. No need to reboot. So let's take the example of this first quadrant here that's showing the performance profile. The chart shows the fact that we can have the example here is for a 24-core processor. We can have a profile of this processor running at a certain frequency, which is the guaranteed base frequency when it boots at 24-core. But if someone would need it to boot at a different profile that is one of the 3 profiles supported by this processor, typically at 16 cores or at 8 cores, it's always feasible to do that in BIOS, and you can say, okay, I only want to use 8 core. But in that case, the base frequency guaranteed by Intel doesn't change for this processor. Yet, you know, and you imagine that you have headroom and that you can get a much higher guaranteed base frequency. The beauty of the performance profile speed select technology feature is that when you choose to boot at this profile, then because you have power headroom, then you can guarantee, we can guarantee a higher frequency with a lower number of cores. And again, if you choose this 3rd profile, then an even higher frequency. Those processors in the Cascade Lake line of product were called something like 82XX, which is the code name, or 62XX, and they finished with a Y extension. Expect them to be available in Ice Lake, but as I said, you don't need to reboot to change the profile. The second one with base frequency that I usually tend to use in conjunction with the core power is that if you want some high priority workloads to run with a higher frequency and a higher priority, then you would need to set this base frequency to a higher frequency so that you can assign the workloads to these cores and they run at a higher performance and at a higher priority. Of course, you can get the best of all worlds. So if you increase the frequency on some cores, you have to allow the other cores to run at a lower frequency. But you don't necessarily care, because what you want is that your high priority workloads run at a higher priority, run faster, and complete in a shorter amount of time. So it's a win-win for everyone. And then the last one, which is the turbo frequency, is that if you absolutely let the processors run as normal, then they will try and always reach the highest level of performance that they can achieve through their turbo profile. But we have seen some customers who absolutely want to guarantee replicability, and then they want to make sure that the turbo is controlled, and you can choose to do that. Of course, in that case, you are ready to leave a little bit of performance on the table. But that's also something that is of use to a lot of end users. Now, what's coming next? So we talked about Ice Lake, which is coming here. And you're seeing here that we are already communicating about 38% publicly, a 38% performance improvement top SKU to top SKU. You will hear more details about this and different performance improvement numbers when we launch it soon. It went into production at the very end of 2020. We plan on putting in production the next Xeon processor, codenamed Sapphire Rapids, at the very end of 2021. And this one will be a major step up in terms of performance, because we are going to support DDR5, PCIe Gen 5, the Compute Express Link that Michael talked about earlier, AMX, which is the matrix version of the AVX, so advanced matrix extensions for AI. And that will be helping a lot on performance for AI, both for inference and training, and some accelerators that will be mostly used for network and other aspects. So very, very exciting line of product coming ahead of us. Sapphire Rapids is a public code name because you have seen it in the node description for the Aurora platform, which is the Xscale machine with the Department of Energy in the US. I don't know if there are some questions. I cannot see, but if there are, please interrupt me. Otherwise, I'll go to the next topic, which is the client CPUs with the focus on the most recently announced and launched processor, the 11th generation core, codename Tigerlake.
Thank you. We don't have any question in the chat.
Good. Okay. So either people understand all what I say, or they don't understand anything, which would be a concern. But hopefully that's the former that is the correct one. But thanks for letting me know. So the 11th generation Intel Core processor, and you remember that I showed you earlier the Iris Xe graphics. Okay, hold on, because maybe, okay, no, I can't see the chat anyway. Oh, I was trying, but I can't. And you've seen the Xe, and I'll talk about it a little bit later in more details. But here, what you can see is that we are talking about a processor with kind of integrated graphics on the socket, with a new CPU, a new GPU, some AI features, and a lot of really good capabilities for the very new laptops. And of course, we are seeing a good usage of Thunderbolt, and moving from Wi-Fi 5 to Wi-Fi 6 really increases the performance at work, and a little bit at home, but a little bit less. In terms of the capabilities, what we are seeing is on the CPU and AI, as it's showing here. Where is the AI used, or where can it be used? It can be used in several places. Typically, when you do video conferencing, then the AI part of the CPU helps with blurring behind you when you don't want to show the background. So the AI is helping making it smoother in terms of movement of the head on this blurred background. But we also have neural noise cancellation on the audio side that is using AI a lot. Wi-Fi 6, as I said, the Geek Plus, as it is called, is really helping up to 6x faster communication in the office and about 3x at home, as per what we have measured. Thunderbolt 4 is also really helpful for access to data which is outside of the laptop. And it is available in the usual Core i3, 5, and 7, and as I said, with the Iris Xe graphics. It is superb for productivity operations, so like what we do at work, but for gaming, you don't need any type of external graphics cards. It's really, really great. And in terms of processing videos and for editing photos, then this is even better. We are seeing, actually, we have measured up to 2.3x faster video editing with this than with the previous generation, and for photo editing, then 2.7x, which is significant in terms of performance increase. We're not talking here about just a little bit of performance increase. We are really going to the next level. And in terms of games, one thing that people were complaining about in the past was that with integrated graphics, sometimes the frame rate was not sufficient to have a very smooth and enjoyable experience. Now, with the new Iris Xe graphics, it's really bringing it to levels that make the movement extremely smooth, as well as the details very, very fast to be displayed. So superb experience. And all this, because it's great to have a CPU, but if you can't do anything with it, so what? Well, as usual, Intel works on developing a whole ecosystem, and in thin and light laptops, then we are helping with the design of a solution that gets the best for everyone, us, the end users, the OEMs, and the designers. So we are providing a kind of reference design that optimizes the solution, both in terms of space, in terms of thickness, so the thinnest as we can, as well as cooling solutions. And that is translated in the new Evo brand name that we have announced in the last few months, and that guarantee a certain level of experience once this logo is put on the laptop. And what does it mean? It means that it is verified to deliver less than 1 second wake from sleep. 1 second, this is very short. It is verified to deliver consistent responsiveness. It is verified to deliver more than 9 hours on battery in typical use with laptop designs featuring full HD displays. And it is verified to deliver 4 hours of battery life in a 30-minute charge, again, on the same laptops. So those are guarantees that if you have an Evo laptop, you will have all of this. Frankly, at the moment, when you buy a laptop, you know that it will be 3, 4, 5, 6, 7 hours, but you never know really whether it will be guaranteed or not. Here, Evo means that it has passed some tests and verification that guarantee that this is the case and that you will have those deliveries that I talked about earlier. So very, very big guarantee of great experience. Okay, so in 2020, we provided Tigerlake for mobile and Rocket Lake for desktops. In 2021, this year, we will be providing the next generation of client processors, Alder Lake, both for mobile and desktops, although their features will be slightly different. But we will have new cores. We will have support for PCIe Gen 5 for the discrete graphics, and there will be new security features. And on the desktop size, on the desktop side, Alder Lake will also support more PCIe lanes up to 48 as needed. And you can see here that the DDR5 will be a significant increase in performance, because if you look at what we currently have with DDR4 3200, if we keep the same number of channels, that means that we will have a 50% performance increase in terms of bandwidth just because of the frequency of the memory interface. And in 2022, another new line of product will be made available, Raptor Lake, that will be using new features, will be providing new enhancements in performance per watt, and as you can see, another important feature for the gamers. They will have a much better CPU cache capability, and that will help with, again, performance, smoothness of the gamers. Let's have a quick look at what Alder Lake will be like and what we are planning to provide. Up to 20 performance improvement on single thread, and that's typically through the new Golden Cove core, which will be reused in some other processors. I don't think that it is public, so I can't say which one it is. And we will be using the super thin process technology that is greatly improving the performance of the transistors in terms of performance and performance per watt. So that's more or less the IPC that we are improving here. In terms of multi-thread, we are planning to again increase the performance. And as you can see, Alder Lake will be a mix of Golden Cove core processors and of Gracemont cores that are, let's say, more atom types of processors. And the goodness is that they are capable of working together in order to, depending on the workload that is being sent to the processor, then which core or cores are best suited to execute it. And of course, there will be the integrated Xe low power GPU. Alder Lake will support PCIe Gen 4, as is the case today, but also PCIe Gen 5, depending on the SKUs. It will support and improve on the connectivity using the best and most recent features that I already talked about. And depending on the SKUs, we will be supporting DDR4, DDR5 for laptop desktops, and the low profile DDR4 and 5 for the laptops. Thin and light, of course, because everybody wants them as light and thin as possible, and with as much battery life as possible. Hence the Evo line of the Evo brand in the line of products. I'm done with the client CPUs. Therefore, if there are no questions, I'll move to the...
Oh, yes. We have one question. Please, König, you might ask by yourself. Okay, let's wait for the question.
So,
sure.
Can you hear me?
Yeah.
Yes.
So my question was, there was a slide 8, Sunny Cove Core microarchitecture.
Oh, that was for Cascade. I'm sorry, for Sky. Ice Lake. Okay. Yeah.
Yeah. The question was, there are 2 FMA units and 1 FMA 512 unit. Can they be used simultaneously?
Yes, absolutely. That's how we achieve the high level of performance on very dense floating point compute. Absolutely, yeah.
Okay, thanks.
Good. Let's move to the discrete graphics accelerators, and I will talk mostly about PonteVecchio, the Xscale GPU. In HPC, we have reached the point where there's a kind of race to Xscale. Everybody believes that Xscale is needed as a milestone to allow new usage, new capabilities for research, for development, and especially in those days of COVID, it is clear that we need a lot of flops, a lot of AI flops also in order to get us out of this pandemic, make sure that we have tested as many of the molecules as we can before releasing them, but that we shorten that time of design. And that's the same in every industry. If we can do things faster, then that will be a good thing for absolutely everyone. And this requires a lot of flops. Xscale requires not only CPUs, but very, very likely some accelerators in order to get those specific, highly demanding operations done in a very high level of parallelism in order to reach this 10 to the 18th number of instructions that an exaflop is. In order to do that, as I said, Intel has been working on integrated graphics solution for two plus decades, and it is working very, very well. You very likely have in your laptop an Intel integrated graphics. We are now making it discrete outside of the CPU up to the point that we will be delivering it as a specific HPC AI targeted ingredient for the HPC Xscale, but all on the under the Xe architecture, just like we have the core architecture, the Xeon architecture, then we have the Xe architecture, which makes a reuse of the expertise that we have here and that we extend to those levels through the mid-range workstations, the enthusiast gamers, and to the data center and AI needs. So there will be several occurrences of the Xe architecture in the same way as there are several occurrences of the IA Intel architecture in Core, Xeon, in Pentium, and in other lines of products. So the same thing here. It's the right product for the right segment. But unlike some other solutions that we see in the market at the moment, what we want to achieve for the HPC Xscale line of product is something which is really built for compute, built for AI, and not something which is derived by keeping some stuff in it that is useless, but that is using power or whatever. What we know is that for HPC, we need a lot of compute performance and a very specific memory design or memory subsystem design, in the sense that, as I said at the beginning, bytes per flop matters. So our Xe HPC ingredient, typically PonteVecchio, is being designed with high compute performance in mind, with scalability, because we are not going to reach 1 exaflop with only a few of those devices. We will need a lot of them. We know that AI is extremely important because the AI workloads and the HPC workloads execute in the same environment on the HPC cluster. We are now seeing a lot of workflows where some end users say, okay, I do a simulation, which is a typical HPC workload. I analyze with AI some of the results. I decide to change some parameters based on this, and I rerun the same workload in HPC and so on. So new workflows are being designed that make use of the server systems, the HPC system, but use them as different types of execution environment. HPC on one side, AI on the other side. HPC for simulation modernization, AI for refining the results. To get that level of performance, we need to have the right memory subsystem. Typically, bandwidth is critical. Scalability is important. Latency is also, and eventually having a unified memory subsystem between the different ingredients of the solution is the need that we are also looking at. This is resulting in a specifically designed GPU for Xscale. Its code name is PonteVecchio, but it is part of the Xe line of product. And as you can see here, it is very modular in the sense that there are 2 tiles, 1 tile here and a second tile here. And then you have the execution units. In the middle, you can't see them very well, but you have what we call the L3 cache, which is codename Rambo cache. It's very fast, very large. You have the HBM stacks. You have the connectivity to other tiles through the Xe links, so that you can get a PonteVecchio to talk directly with another PonteVecchio. And the one that I'm missing is clearly the PCIe or the CXL link that will connect the GPU to the CPU subsystem on the motherboard. So very modular with new technologies called Foveros. And when I prepared this presentation, I didn't know yet, but over the weekend, Raja Koduri, our manager of the GPU line of product, has posted that PonteVecchio has achieved power on and has done its first hello world, if I can say so. I don't know if he has clearly specified what this hello world is, but it's running clearly some applications on Linux. So that's it with the GPUs. Let's have a quick look at what we do with other accelerators like Stratix 10, which is well established at the moment already, with much more performance and flexibility than the previous generation of ARIA. So you can see performance increase significantly, lower power, a lot of flops. And one thing that we don't talk much about here, but that is very important, many more new tools that make it a lot more easy to use. And of course, one API is one of them. I'm not going to go into details of all this, but we can see here that for those who want to do something directly in hardware and that will not need to be changed in terms of functionality on a regular basis, then they can kind of embed their equations and their code into the FPGA to get a much, much higher level of performance and a much better performance per watt. There's a lot of potential flexibility in the integration of the various modules that we are providing. And all this is public. It's just a teaser here to let you know that we have the experts at Intel to help you on this, not only with Stratix 10, but also with the new generation of FPGAs from Intel, codename Agilex, which is the next generation using the 10 nanometer manufacturing process. And all this together allows us not only to provide a good Intel AI portfolio, but globally a good Intel portfolio from client or edge to all of the needs that we can have for Core, Celeron, Xeon, Xe, FPGAs, all of the integrated AI ASICs, as well as coming soon the Habana AI ASICs for inference and training. And I will end my talk with this portfolio that shows that we are providing not only the hardware parts, but as you heard yesterday and you're hearing today, all of the tools and ecosystem that are enabling the best use of those hardware ingredients. With this, thank you very much.